Hello everyone and welcome to yet another recreational programming session with Mr. Zozin. So today we're taking a look at a thing called Cello, which is a library that brings higher level programming to C. Right. I heard about this library quite some time ago, right? But recently I just briefly looked into it and I thought this could be a banger stream to explore this library and stuff like that. So essentially it brings a modern and powerful runtime system, right? So it has a lot of high level capabilities, as you can see. So this is definitely not a standard C, right? This is definitely not a standard C, but it even has like a runtime inspection and stuff like that. And apparently it achieves all of that by adding a little bit of a bloat into the runtime of the language. It even has a garbage collector, as far as I know, right? They even say it's some, yeah, there we go. So here's the list of things that this thing supports, like optional garbage collector. You have generic data types, polymorphic functions, interfaces, type classes, constructors, pure C, not C++, mind you. Pure C, not C++. Constructor destructors, optional garbage collection, exceptions, and reflection. Right. So, and here's an interesting thing. Like, a lot of people use C precisely because it doesn't have any of those things. And the reason why people don't like all of these things who use C is because all of these things come at a cost. Right. They all come at a cost, at additional code at the runtime that you usually don't see. Right. You usually don't see that code because it's automatically generated for you by a compiler. It's perfectly hidden from you, right? So to not distress you, to not think about all of the costs that you're paying, right? So, but people who are doing C, they're actually aware of this cost, right? And that's why they don't really like this kind of stuff. But I suppose this library was some sort of an experiment of like, let's bring that cost into C, and C, what's gonna happen, right? So it's more of like an experimental library. Like, I don't view this library as something serious that you should use in your like production code or anything. I think it's like a small little fun recreational programming experiment, which I actually respect. I like this kind of like interesting experiments that you can have in here. And so let's go ahead and take a look at that, right? So let's download this entire thing. So here's the download button, and download button leads to an archive, right? So which is good, right? So let's go ahead and just unpack it. So just a second, my laptop is a little bit slow, right? Cello, there we go. I'm gonna open it in here, and we're gonna just wget this entire thing. So we're wgetting this entire stuff. Okay, so what do we have in here? So we have a lot of source code, as far as I can tell, right? So we have a lot of source code, and is that just like literally GitHub source code? Is this literally GitHub source code? It could be, actually. Looks like it's basically GitHub source code. Yeah, it is. Except benchmarks, so it doesn't contain any benchmarks. So you have makefile, and I suppose you have to build it yourself, right? So you really have to, yeah, you have to build it yourself. So here are object files. There we go. So, and as if I understood correctly, this entire library consists of basically two components. The library itself, makefile actually built a static library and a dynamic library, which I kind of respect, right? So if you don't want to keep this bloated runtime in your executable, you can put it in a separate dynamic library, which I understand. So this is the first component. And the second component is the header that you include. That's pretty cool. That's really cool. I really like that. That's a really cool way to, you know, to improve the unboxing experience of your library. Just put a huge freaking ASCII art at the top, and when you open the file, it's just like, oh, holy fucking shit. It's literally like an unboxing devices. Like you open the box and there's some sort of like a pretty card there. Like it's just something like that. So it's a 10 out of 10 unboxing experience for the library. I'm telling you, it's a 10 out of 10 unboxing experience. I really appreciate that. So, and as you can see, there is a lot of like a syntactical interesting things. There is a lot of syntactical interesting things. And where are all these syntactical things defined? They're probably all macros. Right, so and the macros cannot be part of the like static library that you're linking with, right? It has to be something with the preprocessor, right? And all of that stuff is located in that header. So because of that, I view this library as a two-component library. It's the header that adds the additional syntax as much as it can, because the C preprocessor is rather limited, right? It's limited in terms of what you can do with this, right? And the actual runtime that you're linking with either statically or dynamically. Another interesting thing in here is that it says it has garbage collector, but garbage collector is a rather complex system that requires some sort of initialization, right? Usually, if you ever used any like additional garbage collectors that you use in C code, they have some sort of a initializer command, initializer function. So you have to call some sort of like init GC at least to start the GC thread and like allocate some memory for data structures for the GC and start doing things. Like you have to do something. Notice how here you don't do anything. Like you literally don't do anything. Like how do you get a garbage collector if you like just start and write normally? That's a very interesting question. Like how the fuck do you do that? Well, from what I saw, it is done with a preprocessor, believe it or not. Modified main, exactly. So we can even try to find maybe something like define main. There we go. So as soon as you include this header, your main is actually replaced with a custom main, which creates a new garbage collector. Like straight up, literally. Here is the new garbage collector. So, yeah. And then it also, it even kind of substitutes, like, look at that. If you have some sort of a main, right, main like that, this entire thing will be replaced with this chunk of code, right, with this chunk of code, which calls to Cello main, and then it substitutes the declaration of Cello main. So when you define a body of main, you in reality syntactically define a body of Cello main. That's what you're doing. So the entry point, like you're not defining the entry point, you're defining like this additional thing, and it wraps it around to initialize the garbage collector and stuff like that. So that's how they do that, right? And that's why the header part of this library is also rather important, because without it, you won't be able to like start and initialize the runtime. And what's cool about this library is that it's rather simple, right? So it's hackable. You can understand how exactly it does all of these tricks, right? So when I saw that, this is the moment I realized, okay, we need to stream that. We need to stream that because this looks fucking cool. If this is the kind of tricks this library doing, this worth worth exploring. Honestly, it's worth exploring. Wouldn't work in C89, needs at least C99. Understandable, actually understandable. But again, I don't perceive this as a serious production ready library. I see it as sort of like a recreational programming experiment, which is rather cool. And if somebody uses this in production, well, yeah, okay, so they actually can be used in production. Okay, let's actually read the answer. So it might be better to try Cello out on a hobby project for exactly. Cello does aim to be production ready, but because it is a hack, it has its fair share of oddities and pitfalls. And if you're working in a team or to a deadline, there's much better tooling support and community for languages such as C++. Exactly. So even the project itself doesn't really take itself seriously, and that's what I like about it. That's what I like about it. It's just like, it's kind of an interesting experiment, and we also don't really take it seriously that much, but if you manage to use this in production, well, I mean, good for you. So this is the shit I like, right? It's just like, not serious about itself. We're just having fun. We're just having fun. We're just having recreational programming. And just for fucking that, I'm giving it a star. That's it. Like, that already deserves a star. No matter how good or bad this library is, just for this attitude, this is a star. Instantly. Just like, I really like this kind of attitude towards programming, towards technology. This is what we need more. And the reason why it has this attitude is because it's a pretty old library. It's coming from the time where the attitude towards languages and towards library was like that all the time. I think the main problem with the modern frameworks and library communities and language communities is that they take themselves too fucking seriously. The tribalism is fucking insane in those communities. It's just like we are the replacement of C++. Don't you fucking dare to stay on our way. We're gonna fucking kill C++. So this is the kind of shit I see. And it's fucking disgusting. Like, and the attitude towards this kind of stuff in the past was like that. This was the attitude. Let's just fucking have fun. Holy fuck. And that's what we need to bring back. That's what we need to bring back. Anyways, I'm sorry. So, let's give it a try. So, let's try to maybe write a hello world. As far as I know, it has its own even print, right? So it even has its own print statement or something like that. Let's go ahead and just like do that. Okay. So, this is what we have. I wonder if I can just do main C. Right, and what we have to do, we have to just include the cello. I kind of instinctively want to pronounce it as cello, but I was actually instructed before the stream not to say it like that because it's pronounced like cello. But again, I don't speak English, so if I mispronounce the name of the library, I apologize, right? So please forgive me. My first language is actually Russian. So what we need to do in here, suppose it's just print, right? So that's what we do. So, and let's just say hello world, right? Let's see how exactly it works. So you know what? I think I'm going to create a make-file. So in a makefile, it's going to be something like that, and I'm going to do cco main.c, and I expect it to not compile. I actually expect it to not compile exactly because it cannot find the cello header. So what we have to do, we have to now give it a path where it is located. It is located in include. So there we go. Yeah. So here's an interesting thing. Conflicting types of cello with int. Ooh. Aha. Here's an interesting thing. If you are defining an entry point, it must be with arguments. You cannot use a variant without the arguments. That is very freaking interesting. Ha! So here's the one basically pitfall and oddity. Right, so because this is what they warned us about in the FAQ, right? It comes with its own pitfalls and oddities and stuff like that. Because it uses the macro to expand this kind of thing, you only can have an entry point that always accepts arguments. Like, you always have to accept the argument. You can't have a variant without the arguments, otherwise it's not even like a linker error, it's a compiler error, right away. And it's a really cryptic one, as you can see. Right, so it's just like it points straight into the header, right? And if you don't understand how the internals of the library works, you might get confused because of that. Audio, like pitfall swipes your drives on uninstall. Yeah, exactly. What was the library that did that? Was it like a Bumble? I think it was a Bumblebee that did that, right? So they put accidentally like a space somewhere, and if you try to uninstall it, it just like wipes out your like user folder or something. I remember there was such a funny incident. Like, it's also a pretty sad incident, right? But it's like it's funny at the same time. Anyways, so we must have arguments in here, and if we try to compile, as you can see now, we're failing with you know, linker errors, right? So let's actually try to link this entire thing statically, right, and see how big of an executable it becomes. Right, so I think it's going to be interesting to maybe even compare. Right, so if I take a look at this thing, so it's a cello A. I'm gonna say link specifically with this one and search for the libraries in this folder. Right, search for the libraries in this specific folder. There we go, and let's try to build this entire, and it builds. Okay, so how big of a file we got? 407 kilobytes, which is not that big, honestly. So if I link it with a dynamic one, right? So let's actually do -b, right? Well, I mean, yeah, so 16 kilobytes, right? So this is, we're linking with this entire thing dynamically, right? So that means it will be dynamically loading that stuff. And if I just use A, right, it basically bakes this entire library into the executable, and we get 470 kilobytes. Honestly, considering like a Rust Hello World, right, if you take a look at the Rust Hello World, unoptimized and shit, Right, so it's, so as far as I know, like I don't have a Rust C in here. Yeah, Rust C doesn't work in here. It's, I think it's like several megabytes if I'm not mistaken, right? So it's several megabytes. So let's give it a try. It's gonna take some time. It needs to warm up some caches. I need to read all of that stuff from the hard drive, and also using like a 10 years old laptop. So anyway, let's actually take a look at le subs. Let's take a look at the subs. 20 seconds. Okay. Thank you, Pakel1, for tier 1 subscription with the message, yo! Enumerate, thank you so much for 100 bits with the message, I'm just a guy who's programmer for fun. Me too. Thank you so much for 100 bits. Andy Author, thank you so much for tier 1 with the message, I'm back, Hypers, welcome back. Really happy to see you. So, and if we take a look at this, it's 3.7 megabytes. 3.7 megabytes. So the runtime of Rust, unoptimized, is bigger than the high-level C Cello. Just to put it into perspective, right? So just saying, right? So you may say that, oh, it's an overbloated like a library, it puts a bloat into C. Like the runtime that Rust bakes into its own executable is actually bigger. So... So, but how is going to be optimized? That's a very good question. How do you do optimization in Rust C? I don't quite remember. I think it's C. I don't remember. Rust C. So something like help. Yeah, and I think it's just something like OPT. OPT level. I don't remember. What was this thing? Who remembers? Yeah, C OPT level 3. Yeah, let's go ahead and do that. C OPT level 3. All right. So, and it's still 3.7 megabytes, so I don't think it actually does anything useful. But anyway, so maybe there is a way to actually optimize the size. Like Rust compiler has a lot of different flags, so I do expect it to have some way to actually strip it off. Strip it, I already removed the thing. Right, so I'm sorry. Anyways, so we're not looking into the Rust today. So again, there are probably some ways, but it doesn't really matter. Okay, so let's actually rebuild this entire thing one more time. And let me see. Okay, so this is Hello World. And how much time does it take? It's pretty fast, right? So initialization of the garbage collector doesn't really take that much time. It's just like a 1 millisecond. And this is roughly the same amount that you would get from an actual C. So which is fine, which is totally fine. All right, so I would like to take a look at some interesting features in here, right? So we have stack objects that are created using %. So essentially you can have var, which is essentially like type inference in C. So var is just a type inference. So if I define something like this, right, so if I define something like this, it just like infers the type automatically. And I wonder how exactly it does that. That's a very interesting question. So let's actually try to compile this entire thing. Okay, so I'm pretty sure it is in fact some sort of a macro. So let's actually do define var. Okay, there's no define var. What is var though? Okay. Oh, fair, I suppose. Like, I mean, okay. Generic programming, by the way. That probably breaks all of the type checking and shit. It probably fucking breaks all of the type checking, because now, if I do something like 69, it's going to complain that it's not assignable to void star. Yeah, the pitfalls and oddities, everyone. The pitfalls and oddities. Oh boy, that's pretty cool. So, but how, like, what is a dollar though? Let me actually see. So do we have the define dollar? There we go. So you do a mem copy. So this is more like an expression. I would like to maybe straighten it up a little bit. What's up with this expression? Okay. So you have var arg, right? So you can have a bunch of shit in here. So you allocate something on a stack. Okay. And then you copy. All right, so there is a special thing to allocate a bunch of data on the stack, and then whatever you put in here, whatever data you put in here is just copied into the stack. I see how it works. I see how it works. Okay, so analog stack. So you just do header any. Oh, so a log stack just declares an array of bytes of the size of the type. I see. Okay, so like how it sort of like allocates any sort of type on the stack. Right, you have some sort of a type. Well, it takes the size of that type, and just allocates like a blob of that size and just basically copies the bytes of that type to that blob. So that's how it is allocated on the stack. And it completely ignores the alignment XD. Pitfalls and oddities, we were warned. So I mean, it's fair, right? Again, like when I encounter things like that in this library, I completely forgive it because it's just like the library is self-aware, right? So it kind of knows that it does this kind of tricks. It also has a header too. Well, let's actually take a look at that. So header init. Oh, it has additional thing. Yeah, which is also just like a var. Okay, so var is like an object in JavaScript, I suppose. So yeah, it's basically JavaScript in C, right? And var is an object, and I suppose through the header you can actually dynamically dispatch on different types, right? So you have a pointer, you probably cast it to the header. Right, and if I take a look at the definition of a struct header, where is the struct header? It probably has like a type tag of some sort. Called it, which is also var, by the way. But I mean, probably, maybe it's just like casted in some way, but yeah. So essentially, Cello operates on these objects, a dynamic objects. So they talked about something like a fat pointers, right? So they had some sort of a concept of fat pointers. Yeah, a fat pointer library. I think it's about its creation and internal workings. So how does it work? I recommend reading a fat pointer library to get an overview of how Cello works. You can also check. Okay. So we're gonna be reading. Where is the article? Reading a pointer library, a fat pointer library. Okay. So here's a full reference documentation for all types. I suppose fat pointer library was something separate, and then they just merged it into. Because if you look at the fat pointer library, it's the official website, I suppose. Right, I suppose this is the fat pointer library. All right, that makes sense. So I suppose vars are the fat pointers. Bottom left articles. Yeah. Just a second. My mouse is dying. My mouse is dead, actually. Okay. Oh, I don't know. Oh, okay. Finally, I think I clicked something incorrect. But anyway, so we became like the article reaction streamers now. Like so. I'm now going to be reading the article and periodically making my pointless remarks and giving my pointless opinions while reading it. So the proposal, fat pointer were proposed by Walter Bright. Okay, do you guys know it's an inventor of deprogramming language? Right, so it's an inventor of deprogramming language. By the way, I really recommend you to Google up about Walter Bright and his work. Right, and also try to look up for his talks on YouTube. He also gives a lot of talks and stuff like that, especially like all the talks. Walter White. Walter White. So he is an incredible programmer, right? He is so fucking knowledgeable. Like every time I find a talk from Walter Bright and like listen to it, I always learn something new. Like he's insane. It's just like so fucking cool. Right, so he knows a lot about programming, system programming and stuff like that. Really recommend. So the idea of fat pointers is his idea. So let's actually see. I want to take a look at the proposal. What the fuck am I looking at? C's biggest mistake. Dr. Dobbs, the world of software development. And it's loading, it can't load. We need to cook seawater. The website is dead, so it's just like, okay, we're not going to be reading that. So as an C extension, M to avoid numerous pitfalls that come from the relationship between pointers and arrays. The problem is this. In C, when you pass an array to a function, it decays to a pointer, meaning what you actually pass is just a pointer to the first element in the array. Wait! Isn't fat pointers what we today, modern software developers, call slice? Pointer plus the size of the array? Okay, so I don't have to read that then, so... I suppose, okay, there are slices, right? So, okay. So it's a fat pointer, it's just a slice, okay. Fair. Fair. Anyways, so let's take a look. So you can actually allocate arrays. So heap objects are created using new. It is almost like a C++. Holy fucking scheiße, meine Freunde. All right, so we can create that. And the real question is, so this thing claims to be garbage collected, right? So it claims to be garbage collected. But does it clean up after itself? Right, if I do something like val grind, is it going to clean up after itself? We just allocated some array on a heap. It blew up with some conditional jump or move, depends on initialized value, but it didn't leak any memory. It actually didn't leak any memory because it has an optional garbage collector. It actually collected it like after itself. It did some weird scheiße, like what the fuck is this, meine Freunde? But at the same time. So maybe they forgot to initialize something, like what the fuck is that? Like why my garbage collector depends on uninitialized data? What the fuck is that? Disgusting. This fucking costing. But yeah, as you can see, we have a garbage collector in C. Who needs JavaScript? Who fucking needs JavaScript if you have Cello? Look at that. Web should have used C instead of JavaScript. If web used C instead of JavaScript using Cello, the world would have been a better place. It wouldn't be a better place. We'd be already colonizing Mars by now. But, you know, JavaScript is stagnating the progress of the entire humanity. That's what happens. That's what happens when you use shady programming languages. Anyways, so... all right, so then we can do for each. I'm actually really interested. Okay, so let's take a look at new. How does new do? It even highlights that. Oh, because I'm using a mode that is also compatible with C++, right? So, so let's take a look at the new. Define new. Okay. All right, so we just pass the variadic arguments as a tuple, as a freaking tuple. You know what? I think I need to do some stuff in here. I want to do e-tags on cello.h. So that basically indices all of these things, and it should theoretically allow me to easily jump around. All right, so if I do something like this, and then I say, okay, use this tags file, and I can actually jump to the definition of this, and look at that. So then I have tuple XP for experienced users, and it's it takes two arguments and just like puts them together. So that's what tuple XP is. This is some sort of like a syntactical, you know, shuffling around. So I don't think it's that interesting. Right, so new width. What new width does not even exist. Look at that. Because we're using this unusual syntax and stuff like that, e-tag broke and it couldn't properly index any of this stuff. So yeah, by the way, so this could be another problem with using this library, is that some parsers may break on that, right? Because again, it adds additional things that are very unconventional for C. So e-tag broke, like I can't jump there, so it is what it is, and it isn't what it is, which is kind of weird. Like it shouldn't break because var is just like a type, so e-tag didn't recognize it as a type. So it's kind of weird. I don't fully understand it. So, it doesn't even, it's just like a forward declared. It's probably an internal function. It's in the library somewhere, so we have to actually look inside. So you know what I'm thinking? I think I need to do the following thing. So let me maybe find all of the files, the name of which consists of like any characters dot, find type file name, like any character dot, and adds with either C or H. Right, let's find all of these files. So here are all of the files. There's not that many of them, only 39, so that's totally fine. And I'm gonna shove all of these files into e-tags, like that. So we're gonna index the entirety of this library. So now we have 45 kilobytes. So there's everything in here. So now, if I just try to do something, yeah, there we go. So I'm jumping inside of the runtime of the library, right? So here I accept the type, which is also like a variable construct. So it's a log, and a log is just this thing. It's just this thing which is not telling me. So it's some sort of a, there's a lot of magic in here. I'm telling you, bruv. There's a lot of magic. So this is the function. And in here we create a new instance of some sort of an object type instance. Damn, bruv, that's like the entirety of, this is like a high level language within C. It's literally like it's a scripting language inside of C. Right, and everything is an object, everything. This is actually kind of cool. Like everything is a var. Var is just a void star, and you dynamically like check, use reflection on those objects to figure out what the fuck is that. Right, so that's what you're doing here. Damn, this this is such a funny library, like holy fucking shit. Like, everything is an object, everything is just a void star. That's how it works. Like it even has self, yeah. Unfortunately, it couldn't like use dot notation syntactically. Like it couldn't easily bring the dot notation to this language. I think it would use it if it could. But yeah, like okay. Notice how like it everywhere it passes var. Like it's always passing var somewhere. Damn, bruv. There's a garbage collector, so yeah. Mark and sweep, I suppose. That's what it's using in here for garbage collection. Anyway. Oh, this library is something, I'm telling you. This is something. Again, I want to take a look at the val grind, right? So if I take a look at the val grind, so how many allocations there were? Right, so there was 21 allocation and 21 freeze, right? So that's pretty cool. Right, this one is a little bit concerning. This kind of stuff is a little bit concerning, but I mean, garbage collector works. At least garbage collector works. Anyways, so we have a for each, right, and it's kind of a cool for each because it even supports like an in keyword. Right, look at that. So, and let's actually go ahead and just like copy paste this entire thing in here. So this is our for each object of a type. So you can even take a type of this entire thing. So make B. All right. So object 5 is of type int. Object 3 is of type int, and this is of type 4. Okay, this is kind of cool. Notice how the printf of Cello doesn't take the type of the variable it needs to print. unlike the classical C, right, where if your object is of type of integer, you have to put D in here. If you pass something else in here, it's going to be completely fucking broken. You don't have to put any types in here. Guess why? Because it uses reflection, right? So it can infer these types for you, right? And this is one of the conveniences that you can actually bring in if you just add a little bit of a runtime cost, right? So you just store the types at runtime, and because of that, since you know the types at runtime, you don't need to ask the programmer to provide the type, right? So we can just grab that type. To be fair, this is not ideal solution in ideal world, because the types, know when the types are also known a part of runtime. Quite often, the types are known at compile time, right? So I think in an ideal world, print, like formatted print functions should actually always use compile time type if possible, right? So compile time type if possible. But we're even not in an ideal world. We are using Cello in C, so this is far from the ideal world anyway. So it is what it is, and it is what it isn't. Can it implement a JIT for this? Dude, do you know what is JIT? Do you know what is JIT? It's a just-in-time compilation. The program is already compiled. It's already compiled. We can say it's ahead of time compilation. So anyways, so yeah, okay, so we got the thing. I wonder if, okay, this is a very interesting thing. Can I now also print the array? So the way you print a thing, you just do it like that, right? So array of integers, and then I can just do something like this. And then I say items. Then I say items. Okay, so if I do something like that. That's some sexy output, except 0x. What the fuck is that, bro? This looks like a major printing formatting fuck up. Like I can even already see how that mistake was made. it's the hexest. It's the hexest value. This is so fucking cool, but bruv, what the fuck is that? Like, I mean, I wonder how did it come to be. So how can we even search for this kind of stuff? I suppose, just a second. Just a second. I want to actually find in source code where that shit happened. So probably the way it works, the formatting thing is this, right? So we're going to be ignoring this stuff at this, so we're ignoring this stuff and also ignoring this stuff, right? So I want to try to grab this kind of stuff, but that means I'll have to escape these things. Let me find, okay, unexpected end of file. So it's probably because of these things. What is that, brother? What is that, bruv? I don't fully understand what you don't like in here. Maybe I should just like not use this thing. Okay, so maybe this is because of that. Found it. I think this is what it is. %p in printf already adds 0x. So this is one of the things that happens actually. So that's the bug essentially. So let's actually go into the main C, into the original main C. And if I just include stdio, I don't know if I need to include stdio, but anyway. So if I do just p, and I just take a, void star like, 69 for 20 or whatever, maybe in 0x. Right, and I try to maybe be main. Yeah. So on top of that, we can say %p already adds 0x. Something like that. I don't know. As you can see, it already adds 0x. You don't have to do that. But what's funny is that, is it consistent across different compilers? Does anybody know? Is the format of %p standardized in any way? Is it standardized in any way? Maybe the reason they did that is because maybe it's not standardized. Maybe it's just like whatever. So I don't know. I'll try to check the standard. Okay. So one of the things we can do, we can try to just like remove this entire thing. On top of that, we can find all of the places where maybe this thing is done like that. Let's actually find all of the places which probably do something like this, because it looks like it's a common mistake. It could be actually a common mistake. So let's actually grab rn specifically for this kind of stuff. In how many places? Okay, so there's quite a few places that do that actually. So it is a very common. I'm not sure if it's a mistake per se, but it's %p is implementation defined. Okay. So it is in fact implementation defined. So one of the solutions to get rid of that weirdness, it would be something like having a macro, right? So some sort of a macro that by default, like let's call it like %p, pp, which stands for %p, right? And essentially you would just do, you know, 0x %p, and if def gcc, right, you actually define pp like this, and if. And basically you have like a chain of if defs for different compilers, right, since it's a like, you know, implementation defined. And then how you use it, you just use it like this, like printf, like pp, some stuff like, you know, something like this, at blah blah blah, new line, and that's how you use that. You just basically embed it in here. Since C allows you to have multi-component string literals, it is going to work, right? So in C, let me actually use SimC mode because it's not particularly visible, right? So in C, if you have something like that, this is considered a single string literal. This is a single string literal, right? So if you have just like a sequence of these separated chunks of string literals, this entire expression, a sequence of tokens, is single string literal. Because of that, tricks like that work, right? So essentially you can define like a custom thing that is sort of abstracted away, and you can easily inject it in here because that will consider this entire thing a single string literal, right? So this is how it's usually done in C. Right, and this is the way I would solve this problem, right? So essentially by default it is 0x %p. Then I would look at different kinds of compilers, right? Check different kinds of common compilers and see for which compiler I need to add this 0x, and I would just like do it like that. So this is how we would do that. But I mean, so the project is already established like that. It's not that big of a deal, honestly, right? It's kind of funny, right? So when you compile this thing with a compiler that does this 0x automatically, but ultimately it's not that big of a deal. It's just a little bit funny, But again, this is not particularly serious library. It's a library for recreational programming. You can add a check to autoconf.sh. Just like there is no problem in computer science that could not be solved with just yet another layer of abstraction, right? Except too many layers of abstractions. So yeah. Anyways, so that's pretty cool. It does a lot of introspection. It does a lot of reflections. I really fucking like that. Yesu. Let's take a look at some other things it does. Okay. So you have hash tables. Chat. They added hash tables to C. Ooh. That sounds like a banger title for YouTube. Holy fuck. YouTube people would click the shit out of the title. I know that. Because I post there all the time, so yeah. They added hash tables to see finally everyone been waiting for this update. Holy fucking shit. C is actually usable language. Oh. Okay, that's pretty cool. So yeah, you can. This is rather convenient, honestly. Right? So maybe I should start using that. Bruv, Brovsky, what the fuck, Brovsky? So apple, banana, pear. All right. So what the fuck is I? What the fuck is I? Huh? It's sort of like a. I think I know. It wraps values into vars. Right, because Cello operates with vars, but integers and string literals, like in a vanilla C, they're not vars. So you need to box them. I remember they were talking about boxing. I do fucking remember they were talking about boxing. I remember that. So let me see. So if I go to learn, yeah, so there's a boxing. Yeah, unique pointer. So, oh no, boxing is a separate. A type is another wraparound C pointer with one additional behavior as compared to ref. When a box object is deleted, it also called del on the object. It points. They have destructors. Holy fucking shit. But I mean, it also has garbage collector, so that means it also calls its destructor when it's garbage collected. This is truly a JavaScript of C. Like, what the fuck? They literally implemented JavaScript inside of C. What the hell? Wait a second. The author of this library wrote a book. Actually, they are a book author. They're a book. Like, who are you? Daniel Holden, I don't know who that is. You may know me from a book I wrote, and the book they wrote is Build Your Own Lisp. No wonder it feels like JavaScript. So, yeah. That's so fucking cool. Man, this is such a cool project. I love it. It's like, it's quirky, it's weird, and it's self-aware of that. It's so fucking cool. I love it. You read that book, so some people actually read this book. That's so cool. The clickbait possibilities for the stream are exactly. So thank you so much, Daniel, for providing so many clickbait possibilities. Damn, this is a cool library, man. What the fuck? What the fuck? So we have hash tables, so we can try to do some maybe word frequency analysis. My favorite exercise when it comes to using hash tables and stuff like that is when I just like take the input, the content of the file, split it by the tokens, aka words, and just like count how many times a certain word occurs in the text. This is something that we can do. Right, so using these hash tables and also the capabilities of this library, right? Because it's sort of convenient, actually. Sort of convenient. So these things, they take the vanilla C values and they wrap them into vars, right? Because by themselves, they're not going to be usable, right? So we can even actually test that. So if I try to do something like this, it compiles. But then I simply replace that with just a vanilla string, and it will probably crash. It didn't crash it, but if I try to do something like that, yeah. So I think I know why it didn't crash with a string. Because a string is a pointer to char. This is a pointer to char. Var is a void star. In C, yeah. So you already know, right? So it's the char to void actually like allows you to do this kind of stuff. So because in C, even if you enable all of the warnings and stuff like that, C allows you to convert any specific pointer to void star and void star to any specific pointer. The only thing that is strictly forbidden is any specific pointer to any other specific pointer. So you have to go through this hoop of first generic pointer and from generic pointer back, right? So because the conversion from specific pointer to generic one and from generic to specific one is too goddamn common in C that it's kind of pointless to prevent you to do that. Right, but if you're trying to convert specific to another specific, that's already kind of sus. Right, so yeah, it's already kind of sus, and this is probably not what you want to do unless you know what you're doing. So anyway, that's why it kind of worked like with strings, but it didn't work with integers. So this entire thing kind of wraps specific values into vars, and I wonder how exactly does it do that, especially with the integers, right? So let's actually take a look at that. So we're gonna do define. Okay. It uses that goddamn stack allocation shit that allocates arrays of bytes on a stack. So to just pass a goddamn integer literal to a hash table, it needs to allocate an array of bytes on a stack, copy the representation of that integer to that array, and give the pointer to that thing to the hash. I'm outraged and amazed at the same time. Holy blow. Yeah, exactly. Holy blow. This is outrageous and amazing at the same time. I fucking love it. It's just like I'm fucking love it. So the way it's just like, yeah, compiler will optimize all of that out, of course. The compiler will just optimize all of that out, of course. This this library is blurred. It is really fucking blurred. I love it. So damn, bro, damn. So and if I try to print this entire thing, obviously, right? So something like this. So we have table. Right. So this is prices, and what do we have in here? So boom, and it prints everything in here with the hexiest of the values. The hexiest, the sexiest. All right. Not just hex numbers, sex numbers. Oh, funny. What else do we have in here? So you can have arrays, obviously. That's pretty cool. So you just define an array, and then you can just have values in here. So then iterate over indices using the range. You can even have slices. Define a normal C structure. Make it compatible with Cello. Yeah, it turns it into a var. Right, var is not really var. Oh my god, this is really fucking JavaScript. So JavaScriptish, damn. So and then, wait. This is kind of bizarre. Just a second. This is sus. How the fuck does it do that? How the fuck does it do that? That broke. The selection is broken completely. But anyway, so that I define the struct, and then it correctly initializes the fields of the struct. How does it? Wait a frick! Don't freaking tell me. Oh my, I think I know how it does that, and I'm disgusted and amazed at the same time. I think I fucking knows how to do that. So essentially you have this, right, so this thing, right, you have type, and you have, you know, VA args. Yeah, it has yeah, people already figured it out. It's VA args shit. Right, so you basically do something like VA args, and maybe, since you know the type, yeah, since you know the type, you can, okay, so that's not that big of a deal, honestly. Right, since you have the type, and it just uses the type, and then it takes the byte representation of that type, right, so of that sort of struct literal, right, it probably just mem copies it, right, it just mem copies it like that or something. Okay, fair. It's not that bad, right, it's not that bad. Right, it's not that bad. And then we just like create either on a stack or I think I'm getting a hang of it, right? So the convention kind of makes sense. It's really intuitive. So dollar just means that it's on the stack. So it does this the entire like byte on the stack thingy. Right. It's very consistent. Like you can intuitively understand how it all works. So you can do comparisons. You can, wait, but how CMP works then? So less or equal. Does it compare? So you can do hashes. Hashes, I can understand how it does hash. It just hashes the bytes. That's fine. But how does it do CMP? CMP is sus. CMP is truly sus. So how does it do that? All right, so let's take a look. I'm really curious about that. So define CMP. Okay, CMP is not that. Okay, so there's a struct CMP. All right. Self and other object. Okay, let's take a look at the implementation of this thing. All right, so we take an instance of CMP. It must implement CMP you can have interfaces and shit, but we never actually said that the pointer has a comparable interface. We never actually said that. We actually never said that. Like, how do you even do that then? This is sus. I don't believe that this is going to work. Chat. I think they're debating us. Just a second. I think something broke. This is not copyable, by the way. They made it impossible to copy. Does anybody understand how the fuck this works? Like, I mean... It falls back to memcmp apparently. Ah, okay. That's very interesting. I wonder if I can just... I don't know how to copy. Maybe it's done intentionally so you don't copy paste code because copy pasting is bad. But if I used like Apple products, I would have just screenshotted this entire thing and just like did OCR and like copy pasted. It's really funny. But anyway, so it also falls back to memcmp. I don't really see. Oh yeah, okay. So if C and CMP available, just returns that. Otherwise, size of the type, type of and type of that, and just memcmp. Okay, so just that's memcmp. Can compare type to type. I'm gonna see. Thank you so much. All right. Okay, that's pretty cool. That's pretty cool. So what other based features do we have? Right, so we explored the examples. Let's take a look at the documentation, right? So this is the boxes that we have. This is arrays, exceptions, files. All right, so we can actually read files. That's pretty cool. All right, so here we write in file. How do we read from a file? So automatic closing. Fuck off. And I'm pretty sure it is implemented in the most blurst way possible. This is such a cool library, right? Because it implements all of this like a conventional higher language thing, but it does so in the most cursed way possible. I fucking love it. How does it do that? Like it's... Well, I mean, it's just like probably wraps around some shit and just like calls this and calls it and whatever. Since you have like the whole dynamic object system, you can just do that. Right. So because files probably have associated destructor with them, right? And it's a dynamic generic object. So, and since you pass it in here, you can just like kind of sort of schedule on a level of preprocessor to call the destructor of file at the end of this entire thing. So it's not that big of a deal. Right, so you can implement that if you have this like a very much dynamic generic system. It's not that hard to do. Right, it's not that hard to do. Can you just read the entirety of the file somehow? Right, so new file here, we're just scanning and we can just like, you know, read some stuff from it, which is cool. So what do we have in terms of strings? I'm interested. So okay, string object. Maybe can I manipulate the strings easily? So definition struct value. Okay, that's cool. So you can do usage definition implements. Yeah. So for example, can I split this entire thing? Split. I should be able to split the string, but it's kind of difficult to see. So derives a log cast copy size. Okay, so this is the interfaces that it derives. Implements assign, cstring, so it's cstringable, format, get, concat. You can concat this entire thing. So what about implementation of format? So I don't see. So scan, resize. Let's see if I can manipulate it easily. Right, specifically I want to be able to split, but if I just Control F split, I don't see anything. Maybe it has something to do with slices, right? So partial, iterable. Come on. My mouse is dead. So if I do split, nah, we don't have anything. All right. So zip, multiple, it's probably like zip in the, you know, the containers and stuff like that. So balanced binary tree. Damn. So an apply function. So you can do functional programming with this thing, right? So you can do functional programming. Oh, fuck off. So you can have lambdas. It's not really lambda, right? So just like... So you take x, which is a tuple of 1, 2, 3, you map them with convert to int function and just then, oh, fuck off. Okay, just okay. I want to see if it works actually. I want to fucking see if this shit works. Okay, so I actually copy pasted it in a weird way, so I forgot v. Right, so here we can define this thing like so. So let's just return 0. And let's maybe reformat the entire thing. Right, again, so we're just iterating 1, 2, 3 strings specifically. Right, and if I try to run, it freaking works. So, but it's just show. Right, show just prints this entire thing, but we can actually print it properly, more or less. Right, so with n and just y. Right, so we can do some, yeah, so it prints them separately, so to speak. And how does it convert string to an integer? Right, it creates a new integer object, and there is a method look from. That's a really bizarre name. What's up with that name? It doesn't look. Position. How does look from? What the fuck is look from? Like, it doesn't even explain what the fuck it does. So it's a function. It's a method of interface show. So there is an interface show. So there's different interfaces in here. And I suppose I can actually find. So here's the show. The show class is used to convert object to and from strings. Okay. So, and the methods are like, yeah, there we go. This is how it works. So essentially, show is a way to convert between the value and a string of value, basically serialize and deserialize in some way, right? And looking is converting from a string to that type. Look is a very interesting name for parsing. Yeah, exactly. It's a very interesting because show is fucking show. Damn, that makes so much fucking sense. Because you show and then you look. It's just in the... Fuck. This is fun. I love it. Look is the opposite of show. It's like in the opposite end. Right. So because somebody shows to somebody who looks. Anyway, I'm like, I don't know. So, and all of the functionality, I suppose, it's hidden within these interfaces, right? So if you want to do something with this is like a proper object-oriented stuff, but in C. Oh boy, oh boy, oh boy, where is my soy? Where is my soy? So this is how we convert that. Yeah, and it needs to be allocated, and as you can see, we're allocating it on a heap, though. Look at that. We are allocating it on a heap because we want to be able to return it. Otherwise, we won't be able to return that. And then we're just mapping it and we're just iterating it. I wonder, okay, so what if I just print this entire thing as a map? Right, what does map even return? Does it return a new array, or does it return some sort of a like iterator that calls convert to int lazily? That's an interesting question, actually. So let's actually see what will happen. It's a object that actually calls this shit, you know, lazily. We can even check it out, right? So we can do something like, right, convert to int was called, like so. So this is a new line. Yeah, convert to int was never called. It was never called. It's a lazy iterator, just like in freaking Python. So, and if you want to do something, right, so you first have to do something. Like, you know, I want to call it access, right? So like in Haskell, right? So because Haskellers like to call a bunch of access, right? So because X is a single element, several X's is access. That's why they do that, because it makes sense, right? So then we can say X in this thing, and then we're printing access just like that, right? And if we do that, it doesn't even fucking compile, mate. Doesn't even fucking compile. What? Okay, so it's something that is sus, my friend. For each, didn't? Oh, it's not for each. God damn it. Okay. Yeah. Only then it actually called that. So you can have lazy evaluation in C. I wonder if you can have infinite data structures, like in Haskell, which are computed as you iterate through them. Can you have something like that? So we need to take a look at the, I think map is an interface that does that, right? Apply function to iterate. So map type is an iterable that applies some callable, okay. I guess you can do that. Yeah. Through map, maybe you can do that. So you have current, you have func, you have iter. So maybe there is a, yeah, so there is iterable, yeah. Class implements by types which can be looped over. This allows them to be used in conjunction with the for each macro, as well as various other components of Cello. To signal that an iteration has finished, an iteration should return a Cello object terminal. Yeah, that's actually very interesting. Okay, so if I want to implement, so there's some examples. But what if I want to have my custom implementation? Not none. Yeah, not none, actually. So yeah, I feel like you can have infinite data structures. Like, I mean, as soon as you go into this generic dynamic domain, you can do pretty much anything at the cost of runtime, right? So it's all at the cost of runtime, as usual. All right, so I think I want to make a small break and make a cup of tea. And after that, we're going to try to implement something in this library. So one of the ideas that I had, I wanted to try to implement the classical example that I usually do, is just like analyze the frequency of words in a text file, right? So we can try to load up the contents of the text file into the memory, the entirety of the file, split it by tokens, and just use a hash map to analyze the frequency. And I want to see how convenient it is to use only the Cello functionality to do that. So read the contents of the file only using whatever Cello provides, split and parse the text only using the functionality Cello provides, and of course use its hash table, and we can just see how well it works. Another thing to use Cello for would be maybe a simple game right? Because it's very much dynamic OOP-ish, right? So it's very easy to create like entities that implement like a common interfaces and stuff like that. You know, like this kind of like simple stuff that works for simple games, right? Not in not entity component system, but you know, OOP-ish kind of entity stuff. Could be also interesting. But I want to do the frequency analysis. I think frequency analysis will be dope. All right, so let's make some break and all right, we are back. So let's actually write some, you know, word frequency analysis, right? How do we read shit from a file? That's the real question. Meine Freunde, meine Freunde. Oh, I think it's file actually. Yeah, there we go. So it's not even a file. So file. Yeah, that's bizarre. Ah. Oh, so URL is actually sensitive to you know, to the case, right? I couldn't actually find capitalized F. It redirected me to some weird place. Okay. But I mean, URL standard actually says that it is, you know, case sensitive, so it's understandable. All right, so we have a file, and I suppose what I want to do, maybe I want to accept, you know, the command line argument, file through a command line argument. I wonder how I can do that. So here I have obviously like args and shit like that, but I wonder if there's any way to work with command line arguments in Cello. Does anybody know? Right, does anybody know? So args, I'm pretty sure there's nothing. So at least maybe it would make sense to turn that into an array, right? To turn that into an array. So taking these arguments and turning them into an array. But I feel like it's going to be kind of difficult. Right. Because, like, how do I even fucking do that? Like, I don't think I can easily do that. Has anybody actually solved that problem yet in GitHub? So if I have already an array, how can I convert that? So there's some examples in here. Cello world. Okay. So cello world.c. Okay, so this is just a hello world, nothing interesting. Iteration. So what's up with iteration? Now it's all of the examples from the front page. So I wonder if they ever actually discussed anything like that, like command line arguments. Command line arguments. Nobody ever discussed that apparently, right? So maybe what people do, they just use a vanilla C approach, right? So they use a vanilla C approach. We can try to do a vanilla C approach if we just simply create an array of floats, something like args, new. So this is, yeah, we are allocating the array on the heap. So this is an array of strings, and this is compilable. So this is totally compilable. Maybe one of the things we can do, we can just iterate through each individual argument. All right, so argc plus argc, and just push each individual argument into the args. But the question is, how do you do that? How do you even do that? So do you have something like, oh my god, we have interface push. All right, so what if I do something like args push, right? So there is a method like literally push. You can do push args, but then if I want to do argvi, right? So if I want to do argvi, how do I even freaking do that? So obviously this may not work. I might try to do something like this, right? So because I'm taking, so there's not that much difference between string literals and, yeah, so I may say, okay, allocate that on this stack. So I think that's fine. I think that will work. And after that, I will say, okay, just print this whole thing. Just print the args, and we can see what we can have in here. Okay. I think I fucked up something. You didn't see shit, okay? You didn't see shit. All right, so we got an array, and it's just main. Okay, so I think I forgot to put a new line in here, right? So I forgot to put, yeah, there we go. So here's an array. And we can just do full bar buzz. All right, so look at that. Plus plus J moment, exactly. So we can, like as I already said, my challenge is to use as much of Cello functionality as possible. Because of that, I feel like I must parse command line arguments using Cello mechanisms as well. Right, so maybe we can do something like this. So this is going to be args as array, right? And in here, we're going to just like accept the whole thing like that. And we're going to return var. And essentially, I'm going to be just doing it like this. So args as array, argc, argv. Right, so is it going to work? And it's seg faulted. Because I forgot to return args. Understandable. There we go. And now it works. The cool thing in here, actually, believe it or not, is being able to for each this entire shit. So arg. Man. This is so cool, actually. I fucking hate how cool it is, actually. Even though it's kind of like additional bloat, but it's fucking cool. Like the fact that you can just do this kind of thing. Yeah. That's dope. That's fucking dope. I like that. So args is an array. But here's an interesting thing. So you can, okay, you can do push at, how do I pop things? Right, so I pop them from the, at the given key 0. Okay, so we can try the following thing. So here's my args. So this is my args. And then I just do while, so there should be something like a len args, or maybe even empty. While this entire thing not empty, I don't know if empty exists or not. What I'm going to be doing is essentially pop at, so args I0, pop arg0, and I just like print this entire thing. I might have as well even inline the whole thing. So do we have in the array any interesting methods? What kind of methods? So array is a type data structure. So derives size, it has a size. So interface, I really like how easy it is to explore the documentation as soon as you understand the interface mechanism of this library. Right, so each type implement a bunch of interfaces, so you probably, yeah, so this is kind of convenient. So we have size in here. All right, so that means we can just do something like size. Size is greater than 0, so while we have that, we're just doing this kind of thing. So this is arg, and let's go. And it doesn't even compile because it really doesn't like that. So where is the pop? So pop at pop the object from object self at a given key. So maybe that means I have to do something like this. Is that what it wants? Maybe that's what it wants. Pop at void values. Ah. Oh, I see. Yeah, I see. So that means first thing you have to do, you have to get a value out of that. So there is a get. So you get args at 0, and then you, okay, I see. So it's two separate things in here. And yeah, we've got some weird stuff in here. And what's funny is that it didn't, we went out of this stuff. That means the size was not modified. The size was not modified. Let's take a look at the size. So this is going to be something like this. So percent size of args. So what you don't like? I don't understand. Am I? It's probably not size, it's probably len. But I mean, it is size. Just a look at that. So it has size, right? Size. Yeah. So here it is. It's size. Ah, yeah. You're right. You're right. Okay. So this is the pitfalls and what was the quirkiness, right? Pitfalls and weirdness and quirkiness. All right. So when I do get, yeah. So it returns you literally size t. It doesn't return you the var object. Doesn't return you the var object. Size is weird. So size is weird. Size is not what I would expect in here. So it returns something bizarre. Size is size of... Ah, fuck. I see. All right, so what do we have in here? So how do we do the length of the objects then? Oh, it's just len. Okay. All right. So that means we have to do something like this. Right? Okay, so now it works. But do we have to still wrap it into the object? Yeah, so this is the problem is that, yeah, you can't do that because it's not compatible, but yeah. So, and that's how we can operate with this entire thing. That is very cool. All right. So the reason why I want you to do this kind of stuff is that now it's relatively easy to just have a program name, right? So where I simply get, you know, args I0, right? And then I pop at args I0. I don't really like the fact that it's two operations in here. I really don't like the fact that it's two operations. So you know that I like this shift operation that accepts an array, right, and it just like pops out from the left and returns you that value while modifying the original object. I really like this kind of thing. So it's basically a combination of get 0 and pop at 0. So we can try to introduce that. So this is going to be shift, and this is basically the access, which is also a var. And we can combine this entire stuff together. So this is the x, which is get access at 0. Right, then we do pop at access at 0, and then we return the x. So that's what I want in here. Right, and so that's what will allow me to do shift args. There you go. And then I can do print program name, which is something like that, program name. So it would be kind of nice to have like a cello highlighting, some sort of a cello highlighting. I wonder if there is a package for that. So let's actually see. There should be something. Cello mode. No, there's no cello mode. Look at that. That is kind of weird, my friend. So orange duck. I'm surprised nobody done that. It loads too long. Anyway, maybe I just have to wait a little bit. No, there's nothing. You can switch to JS mode. You're a genius, honestly. Damn, JS mode totally works. Oh my god. It works better than I expected. What the fuck? Alright, we're doing JS now, I guess. Anyways. It even highlights int. I didn't expect that. Like, what the fuck? Why does it highlight int? So now it's perfect, right? So if I try to do something like this, now it works. So the reason why I want you to do it like that, so is that now len, if len of args is actually less or equal than 0, right? So we can always do something like error, no input is provided, right? So, and on top of that, we can even do something like print usage. So this is basically the program and just input. So this is the new line, this is the new line, and this is the program name that we got. And here we're gonna just return 1. Yep. So we provided some input, but yeah, a segmentation fault. Nice. The fuck is that? Why did it segfault it? Why did it segfault? I didn't expect that, honestly. Let's try to find out where exactly we can actually compile, maybe, what if I enable all of the warnings and all of the extra stuff? Right, so maybe we'll be able to catch something. No, we didn't really catch anything useful, but now at least we are compiling with debug information, so that means we can use a debugger, the tool, the scary tool that a Twitter tag absolutely batshit scared about. They would never fucking touch this tool because it's too fucking scary for them. All right, so let's actually do gdb main, and we can just try to run this entire thing, right? And now we know exactly where it failed right away. So it's on the printing actually. So let me see. So something like that. 24. So it's here, right? That's bizarre, honestly. So if I don't print this program name thingy, so what is going to happen? So it's going to be fine, right? So we extracted the program name, but it's not printable for some reason. Should allocate it in a heap. Maybe it should allocate shit on a heap. So we get this. Yeah, okay, so access. So as an array, so this is allocated on a heap. Maybe it has something to do with... Maybe it allocates these things on the... Yeah. This is what I thought about, actually. This is what I thought about. Maybe we have to do something like this. Let's give it a try. Aha. Type of has magic? No. New string return. New string return. We already allocate an array of strings on the heap in here, right? And just do it like that. But I don't think it's. I feel like it must be in here. Something. It must be in here. Yeah, it has nothing to do with this kind of thing. There's nothing to do with this kind. I'm pretty sure it's somewhere here, right? It's not even about shift. I can inline the shift. You're leading me to a wrong place, chat. Stop, please stop. Right, I can even inline, and I'm pretty sure it will still complain because it has nothing to do with shift. Right, I'm gonna even comment it out, and I'm pretty sure it is going to sec fault. So what is it saying? It's args, and this is another args. It's not about shift. It's not. Yeah, it's right. You're leading me to a wrong place. Okay, so I feel like what it does, it copies the string to the stack in here, and that's not what we want to do in here. Actually, this is not what we want to do in here. So let's actually see. All right. So what do we do in here? So define. New, right, so we define that, and then we define var args. So there's also new row and new root. I have no idea what they mean, but it's kind of hard to tell. So new width as well. Well, I mean, it's just like redirects to here. Okay, so maybe what I have to do is a new string. This is what I feel needs to be done in here. This is what I feel needs to be done in here. So it has to be copied like that. But it doesn't like it. As a bad magic number wasn't allocated by Cello. So maybe, yeah. How can I even duplicate that? Like I want to allocate a string argvi needs a wrap. Aha. But does it need, does it really need a wrap? No. This is nasty. This is fucking nasty, Nate. So fucking nasty. How do, like, I mean, this is allocating on a stack, but we're trying to allocate it on a heap already, so this is not how it works, right? So you're leading to a wrong place. Okay, chat, I'm gonna just put a sub mode soon, if you're gonna continue doing that. All right. So this is allocating, okay, so I need to have a bunch of strings, examples for strings. There's not that many examples for a string. Right. All right, so you can, so they do actually that. right, with S, where you just have it allocated on the stack, but then you do this additional, yeah, this is kind of weird, but I suppose it works. I suppose it works. Okay, so maybe that's the thing, but it doesn't make sense. It actually doesn't make sense. And here, yeah, it still says false. So we can try to maybe it's false for a different reason now. BT, let's run it. All right, BT. Yeah, it still doesn't like that. Still doesn't like that. So that is bizarre. I really don't know what's up with that. Why does it not like what I'm doing in here? So this is on a heap. I'm just iterating through this entire thing. Then on this heap and I'm just pushing it. You need to wrap on a print also. I do not believe that because it's already a var. It's already a var. I shouldn't printing it. Wait a second. When I do get, so where is the get operation? We may take a look at this cell. I'm surprised I'm wasting time on this. Yeah, it's a var. Like I should not do in wrap for var. It's already var. So like, why am I wasting time on that? This is unacceptable, honestly. I don't like that. I don't like the fact that I'm wasting time on this. Like, I should not be doing that. Yeah, well, I mean, at least it works, but it's a garbage, right? So that means I should not do that. Means I shouldn't do that. What's, like, how do you do that? Like, I'm obviously doing something wrong in here. I'm obviously doing something wrong. Okay, so copy, that's a good one. Somebody said smart things, finally. Chat saying smart things. So there's a copy. What's up with copy? Copy class can be used to override the behavior of an object when a copy is made of it. Copy object. Okay. So, can I just say copy? So, and yeah, so we're just copying this entire thing, and copying, actually, the copy is registered with the garbage collector as if it had been constructed with a new. Perfect. This is garbage, bruv. I'm disappointed. This is garbage, bro. Okay, I can get it, sure, but then can I get? Wait, don't fucking tell me. It probably removes it from. I think I know what the fuck is going on, chat. This is me right now, yes. I think it fucking nukes the object when you pop at. I think it's literally what it does. It just like nukes it. So that means... Oh my god, so that means what I have to do, I have to do copy not here. I have to do copy here. Bro. Yeah. Like, copy needs to be done here. Because I feel like pop add like literally nukes the object out of the heap. Garbage collected my ass. That's everything I have to say about this garbage collected language. How is that garbage collected? It's not really GC then. Yeah, exactly. Like, what the fuck is this? And it's also, well, I mean, it exited abnormally and stuff like that. So that means I don't have to copy in here. I feel like I don't have to copy. Yeah, so I don't have to copy in here. So copy in here is not needed. So yeah. So what we have to do copy in here, and only then we'll be able to do shift args, and that will work properly. Optional GC. So okay, yeah. So I suppose I can disable it maybe. So pop goes back to CPU stacks, so pop would move the pointer after the copy, that is why it removes the element. But I still hold the pointer to the thing after I popped it, don't I? That's really bizarre. So that means things... Wait, are you telling me things on the stack are not considered the root of GC? Are you telling me things on the stack are not considered the root of GC? I mean, it's a funny little library. What do we? Let's not be too harsh to it, right? It's fine. It's fine. Anyways, so yeah. Here, what I want to do, I want to do file path, right? So we figured that out. Everything's fine, chat. Everything's fine, right? So shift args, and here we can just do something like a file path. We'll eventually get a hang of it, right? So we just have to burn ourselves several times on different pitfalls, right? So they warned us about pitfalls. Here they are. Here are the pitfalls. Yeah, so no input is provided. What we can do, we can provide our own source code. There we go. So in here it is file path. We managed to do everything successfully. Oh, no fucking way. Just a second. All right. So cell h pop at. Can I? Maybe here. How can I even do that? I don't freaking know. So where's the method pop at? So probably have to do something like grep or n pop at. Yep. What the hell is that? Push definition. I didn't see it honestly, but anyway, it's in array C. Okay. Pop. Oh, so it's this one. Okay. Yeah, it distracts the item. I see it now. What a shame, bruv. Why would it distract it though? So that's kind of doesn't make any sense. I wouldn't expect it. Like, yeah, you're in a garbage collected environment. We just let the garbage collector do its thing. So as if it's yeah, it's owned array. So combining these two kind of models of management together doesn't make any sense, right? So you either do the ownership model thing, right, or you do garbage collector where everything is just like allowed and you just like let the garbage collector do its thing. Like you can't combine them. That creates a really huge dissonance, right? So that results in this kind of situation that results in wasted time. So both is not great. Yeah, I agree with that. But maybe there is a reason behind that. But I mean, we just demonstrated that it's kind of bad, right? By wasting like a little bit of a time, we demonstrated that this kind of approach is kind of bad. So you probably don't want to combine these kind of things. Maybe you want an array of ref of strings, maybe. So I'm not really aware of the concept of ref yet, so maybe I need to learn that first. I kind of vaguely remember the concept of ref in Cello. So anyways, so we have a file path. How can we read? So I have cock in here opened up. Why do you have cock? Anyways, so let's put away our cocks and open files. It opened the wrong thing again. God condemn it, mate. So file. Oh yeah, you even provide the type thing in here, which is kind of funny. So for writing, but what about reading though? Okay, so here's the reading. I can open file for reading. I can have some sort of a buffer into which I'm reading, and yeah, that's really interesting. So the problem here is that I can't really see the methods of file, right? Does the file have any methods that I could have used? Right. So well, I mean, we have these kind of things. Doc format. Okay, so you have stream. Okay, so it has this classical sseek, sstyle, sflat. So, all right. So maybe we can implement read the entirety of the file through this thing. That's one of the things we can do, right? So we can essentially figure out the size of the file. Yeah, it's basically like a POSIX thingy. Yeah, it's a POSIX thingy. So then we can resize. So you can even resize the strings, right? So we can allocate the string and just return it like that. So what I want to have is a read entire file. That's what I want to have. I think in 2024, like every language should just have this function, like read the entirety of the file. This entire model of streaming files in 2024 with modern computers, I feel like it's kind of outdated, isn't it? Right. So we have so much memory, and we rarely work with files that don't fit into that memory. Right. So, and what we end up doing, we just end up like reading the entirety of the file into the memory. Sometimes you may have labs in the 30 gigabytes XML. Well, I mean, yeah, sometimes you may have huge files, but I wonder, can you just memory map that file? Because I know that on Linux, when you memory map a file, it's not read. Yeah, just map it. So Chris says that you can just map it. And I believe Chris, because he probably worked with this kind of stuff. So when you map a file, it's not read into the memory immediately. Right, so it's read as you're trying to access the pages where the file is mapped, right? And the pages are not actually mapped. So when you try to access them, some sort of interrupt is issued, right? And then kernel looks at the interrupt and says, oh, let's just map this page, right? And then continues your program execution from where you were trying to access that page, and you kind of slowly reading that file. But the question is, does the operating system unmap some of the pages of the file over time if they were not accessed for too long? Is that something that operating system does? Right. So that means if it does so, it's kind of like a combining best of the both world of reading the entirety of the file into memory and also streaming API, where you can just memory map a huge file and just slowly process that file from left to right. And that will basically be in terms of like accessing the actual file as the streaming API, but in terms of convenience, is going to be like reading the entirety of the thing into the memory. Did I understand that correctly, or I'm just saying bullshit because I'm not sure? So yes, and you have hints to tell the OS that you will. Fuck. You know what's funny? I have a dead row of pixels on my monitor, and it actually covered this entire row, so I couldn't actually read it on my second monitor. This is, by the way, I'm buying the new laptop because the pixels on this monitor are literally dying. I have like patches of dead pixels in here. This monitor is pretty much unusable. Right. You can hint to tell the OS that you will access the file streamingly. Nice, that's very interesting. Just like usual swap mechanism, it can just unmap them as necessary. This is actually kind of cool. So because of that, it just like doesn't make any sense to not have an API of read entire file. I think this entire streaming API is just like leftovers from older days when it makes sense, but it doesn't make any sense anymore. But we kind of stuck with it because a lot of code depends on that stuff. It's kind of funny, interesting. You didn't switch to. I didn't get my new lap. Well, I mean, I do have a new laptop, but it's a backup weak laptop, and I'm not sure if I can stream from it. So, right. So it's a laptop specifically in case this one dies, so I don't lose a computer on which I can do things like send emails and just access my accounts and stuff like that. So it's literally like just an emergency laptop. It's super cheap. It's like $300, right? But I mean, it's not that cheap. Like I could have bought Feasting. Forget everything I said. But I mean, still, it's just like my emergency, like a backup laptop. So, read entire file. So, file path. I'm gonna read that scheiße. So what we're gonna be doing? But can I actually do that on this stack? And will that mean that when we, well, I mean, I can just do this, right? So with, and let's go. So f in new file, so this is the file path, and I'm going to be reading it in binary. Damn. So then I suppose I'm allocating the result, maybe I'm going to call it the content, and that's the thing I'm going to be actually returning. Right, so I'm returning this entire thing. And all that stuff doesn't really matter that much, I think. So this is the string. So I want to async this thingy. So this is the file and position and origin. But the origin, is it the same as, how do you use that? Because if you take a look at fseek, right? This one is not the origin, it's a whence. It's whence. But what the fuck is that shit? Seek origin. Okay, so let's go into the source code of Cello and maybe just literally grab seek and hope that there's some examples on how to use this thing. Right, do you have any examples on how to use this shit? Not a single example. All right. So there are some methods. So maybe I could do something like this. So there's a method stream seek. How? What's the name of the actual thing in here? So if I do method, you define in the method. Offset of, and you're just like looking for this thing. So stream cello. So seek to the position pose from some origin in the stream. I'm just trying to figure out the size of the file. But there's not a single example on how to do that. One thing we can do, maybe, if I manage to find the actual implementation of seek, because I haven't learned how to search for this for methods, where is the actual method implementation, right? It's kind of weird and quirky and stuff like that. So whether just to seek. So there's a process seek. So there's a, yeah, okay, so it's called file seek. Okay, it's file seek. And how do we even do that? Oh, it just pushes it to fseek, which is a POSIX seek. Okay. But it's not the origin, it's a whence. And whence is basically allows you to do things like, bro, do you even know how fseek works? And it's a question to the creator of this thing. So seek end. Right. So it's not a specific origin, like it's a enumeration which gives the meaning to the offset. Depending on this enumeration, the meaning of this variable is just different. That's what it is. Like, so, and the only reason I can understand how to use this function is only looking at the implementation and just confirming. Okay, so you're just using POSIX, right? So it's not really origin, it's they renamed the param name. Yeah, it's just like anyway. So fseek, we've got fseek. So we got to the end of this entire stuff. All right. So and then we do stel, which gives us the size of the whole thing. So stel of f, and so that means I can resize the content to size, right? So I'm resizing the content to size, so that after that I can just read it. So, but that means I have to set like this, right? So as you can see, depending on this enumeration, right? So 0 just means a different thing. So it's a 0 from the end, and this is 0 from the beginning, essentially, right? So, yeah, that's what it is. So we're reciting the content, and how do we read the whole thing? Okay, so there should be something in the stream. read. So you can, okay, so we just do s read. It's a f, and this is the output, and it's not even a string, bro. How do I read into a fucking string, bro? Okay. There's some shit like scan from and stuff. Okay, so where is it coming from? Scan from, scam from. I don't know where it's coming from, honestly. So because it's not defined anywhere in here, so it's kind of hard to tell. Scan from, so there's a scan. Can you just like, is there any read? So there's a stream s read. What I want is just a read n bytes into a string object. How do I do that? Can Google? No. Google can help you if you have types. We don't have types. So there's a C string. Okay. C. No, there's. Well, wait. Aha. All right. So that's a good idea. Okay. So let's actually take a look at the C interface, like string interface. That's what I want to say. So it has a C string. Returns the object representing. Should be overwritten by types which represent it. So I suppose C string doesn't do any copies and just returns a pointer to the buffer internally. So you should have to manually null terminate it, probably, maybe. So let's take a look at how this thing is implemented. Yeah, thank you so much. By the way, Chris, I think I need to give you VIP. Just a second. I'll go, you are VIP now. So let's take a look at what it does. Yeah, it just returns a value. Okay, so it's pretty straightforward. So that really means that I have to null terminate it. Okay. Which is, no, I really don't need to null terminate it because I'm not going to be using it as a C string. I'm going to be using the C string method just to get the pointer. Right, so I don't really have to do that, I think. So CSTR content, and that's the size. There we go. So that should be it, honestly. So if I try to compile, well, yeah, let's go and find make. Okay, so that seems to be working. So read entire file path, and this is content. Right, and then we can just print that content like this. Ha! I mean, I don't know. There's lots to unpack in here. Let's put it this way. There's lots to unpack. If the string, can you just print it as a string, bro? Like I have a string, just print it as a fucking string. So yeah, cool. But at least we managed to read. Oh, maybe it's a debug output. Maybe that's a good point, actually. So let's actually find maybe print. You know, it would be kind of cool if the header itself also contained documentation about the functions, like, you know, in case of raylib. You know what I'm talking about? Raylib, right? So in case of raylib, you right, so you have documentation in here, just a little bit, that explains how this entire thing works. I suppose this thing is created for people who primarily going to be using this documentation, but I mean, I quite often like to look into the source code. So it's really printing it character by character, huh? Maybe, I don't know. So formatting. So I'm pretty sure there should be like a format interface, right? So, and this is where we're gonna be looking at the documentation for, yeah, for how this entire thing works. So read and write from format strings. And there's no information about that. So for like how this entire format thing works. So I think S will string as string. Okay, probably. Let's give it a try. Okay. Also, that means you need to specify the type. I wonder if you can just do it like that. Nah, it has to be. Can I just say, is there any like a generic way to say, bruh, just print it as whatever type it is? Right, if it's a string, print it as a string. If it's an integer, print it as a... Is there any way, but not in a debug way where it escapes special characters? Because I don't want to be thinking about what type it is or whatever. Yeah, it's like a dollar is like a show in Haskell, right? I want to be able to say like whatever it is, just print it as whatever it is, like normally. And okay, we can take a look at how it's implemented though. So let's see. So print. So print with. All right. So what do we have in here? Okay, so it uses format 2. Huck2. Pepper Paints. Oh yeah, it's like I freaking hate these things. All right. So maybe it's something like format 2. Is that how we're searching for them? Yeah. So what are the methods? Yeah, so string format 2. Yeah, things like format 2. vprintf. So it's probably just piggybacking of the thing. Yeah, but just using the standard printf for this kind of shit. All right, whatever. So I think it doesn't really matter that much for me. Cool. We managed to actually like parse command line arguments. We managed to print this entire thing. And honestly, things like this, like representing arguments, command line arguments as the array, then shifting, like popping from the left without killing the whole thing and reading the entire file, the functionality of this function should be part of the library. I feel like if the library is here to be high-level C, I should not be doing this kind of things. But some may say that reading the entire file is just like a taste, right? It's sort of like a preferential thing. But at the same time, I don't think so, right? So because like that's what you want to do anyway in the 2024 when you're reading file. You just want to read the entirety of the file and that's it. Right. So I feel like the library is a little bit old-fashioned in that regard. And it is, in fact, old library, right? So I remember this library when I was in university. I graduated in 2013. How old this library is actually? Does anybody know? So it's not really modified that often, right? So 3 years old. So what's the easiest way for us to actually find out how old it is? Can we just git like a git clone the whole thing? Is it going to be too much for us? Only 300 commits, so I don't think downloading the entirety of the thing would be too much. Yeah, it was actually pretty easy. So I just want to see how old it is. Well, that's looks about right, honestly. Yeah. Yeah, so it's 12 years ago. It's pretty old. So yeah, it does feel like a little bit old-fashioned in that regard. Because again, I remember like if I graduated in 2013, right? So minus like 12. Yeah, roughly. That's around the time I remember about it. I think it's like when it came out. Damn, I'm so fucking old, bruh. Bruh, I'm so fucking old. Holy shit. Disgusting. I'm also so grumpy. God damn it. Anyways, so let's continue. John Blow is probably looking at me and laughing. Anyways, so we read the entire thing. So the next step would be to actually split the file into like tokens, right? But let's actually start with lines. So let's take a look at what we have in here. So is there any way to split things? So I think the easiest way for me to find out is to maybe grab this entire thing, like so. Maybe even src, maybe even Cello .h. Split. There's not a single mentioning of split in the entirety of the header. In any freaking way, in any case. Okay, so let's take a look at the source code itself. Maybe it's just called kind of differently. I don't fucking know. Rest in peace, Sodium. Yeah, exactly. Split. So you're telling me there's no way to split this entire thing. We'll just end up writing all the abstractions at this point. Yeah, exactly. So, so already streaming for 2.5 hours, and I think it's too much already. So we're gonna call it at that. Right, so I'm going to rename this entire thing to cat. Right, so this is basically cat. And I'm gonna say that we didn't implement the like a frequency analysis tool. We implemented cat. But this is not a real cat, honestly, because cat accepts several files. It concatenates several files. That's kind of the point of this entire tool. All right, so for example, if I do like this kind of cat, where I do cat make file, right, so it just actually prints them sequentially. So if I try to use my cat, it doesn't really do that. It doesn't even exist. Just a second, I need to rebuild it. Right, if I try to do it like that, yeah, so that's a weird. Some string type does not implement class C. So yeah. Anyways, so let's actually try to maybe fix that somehow. Oh yeah, okay. So this is probably what I need to do. So let's rebuild this entire stuff. Yeah, there we go. So as you can see, it processes only one first argument. Right, it processes only one first argument. So one of the things we can try to do in here to make it like a proper cat is to just iterate through all of them. How can we iterate through all of them? We can do for each. Right, so it's going to be file path in args. Right, so something like that. And because of that, we don't even have to shift anything in here. And if I try to do something like this, it just worked. That's how easy it is to modify your program using Cello. That was actually kind of cool, honestly. That was super fucking cool. So yeah, so we can even do something like input, like let's go to files ... That's what we have in here. No files the provided. So we've got a cat program, right? So yeah. So what's my verdict? What's my verdict? It's a pretty fun recreational programming library, which is slightly outdated, which is probably because nobody really uses it. Right. So I feel like if somebody actually sat down and tried to use it in production, they would notice all of these pitfalls and would try to fix them somehow, maybe contribute like a reading entire file or do something like it lacks some content. You know what I'm talking about? It's a very cool engine, right? Because this entire thing forms this dynamic engine, right? But there's not that much content within the engine itself, right? And the reason why there's not that much content is because people are usually probably don't really use it that much anyway. And they don't use it that much anyway because it's not really a production thing. It's more of a recreation, programming, fun project and stuff like that. But overall, I think it has a potential of becoming kind of a useful thing. Right, if you had like more utilities in here, it's kind of cool how quickly you just can ramp up the development, right? So because you can right away to have like a hash table, dynamic things, and it's just prototype things. It's really cool to prototype things in this stuff. So yeah, that's basically my verdict. Just use JavaScript. Yeah, these days you would just use JavaScript. But I mean, it's a library from 12 years ago. So maybe 12 years ago it was kind of cool. But at the same time, I mean, it's more lightweight than Node.js, for instance, right? So, and it gives you a self-contained executable, right? How much of a self-contained is it? It is pretty self-contained. Look at that. It only depends on libc. That's already better than Swift executables. Just saying. That's already better than Swift executables. So anyway, dude, and Swift doesn't even have a garbage collector. Fuck Swift. Oh, this thing has a garbage collector. It's kind of weird garbage collector, especially considering like pop add thingy, which just nukes the elements after you pop them out, right? So, but still, so yeah, how about that? So it's a really interesting thing. It's a really interesting thing. That's my verdict. Cello, very interesting thing. Has a potential. Probably would never realized, but I don't know. Maybe. So Yesu. So thank you so much, everyone, for the subs. Let me see. Nekdilim, thank you so much. Chris Parent too. Thank you so much. DFLO. Thank you so much for Twitch Prime with the message. Tsodin a Panger. Rare legendary white Panger. Look at it. Look at it. All right. I guess that's it for the day. That was super fun. Thanks everyone who's watching me right now. I really appreciate it. Thank you so much, Tigot. Thank you. Have a good one, and I see you all on the next recreation programming session with Ahu. I'm Mr. Azazin.